All right. First of all, a comment, and that was when when I was an instructor at Boeing. This is before calculators. It was really easy to teach dBs on the slide rule. All right. By the way, a comment here. My sign. You see what my sign is here? Das Funk Room with their antenna. Does everyone see that?
Yeah.
It's right on the sheet here.
Got it.
Okay. The reason I bring this up is it's appropriate, if you will, because the name Funk is a German name that used to mean spark, and now it means radio.
It's radio. Yeah.
This is a sign I have hanging up over my radio room, so it's the Funk room. In other words, the radio room with all the antennas. So just throw that in. Okay, Federal Way topics. First of all, does everyone know you can go to my website and click on Edway, and it takes you right straight to this page. Okay. Now unhook one earphone so I can hear what I'm saying. Come on down here to the bottom where it says today's date. dB's the easy way. All right. And here we go. Here's something I came up with. It was rather interesting. I found that there is an interesting comparison between decoding resistor color codes and decoding decimal values. Decibel, not decimal. All right. Here's what we find in color codes for resistors. Well, we know that the first two bands indicate the value. It could be 39, which could be 3.9, 39, or 390. We know that. How do we know what's what? Well, the fourth set away, besides the tolerance, the third band is the multiplier. Well, everybody knows that. Well, as it turns out, when you get into decibels, it's the same thing. Let's take a look at this. The basic decibel value is the value that converts logarithmically to the factor, the gain factor, or the loss factor, whichever you want to call it. The number to the left of that basic decimal value is called the multiplier as the power of the base 10. Now, we're going to give you some examples of that. So I'm going to bounce back and forth on this page. First of all, on a slide rule, it was really easy. You could go down the log scale and you could go whatever dBs you wanted on the log scale. Then you look down on the C scale, and lo and behold, it would show up as the value, the multiplier. There was, whether it's a gain of 3, 10, 12, whatever it might be. Well, in this case here, understand one more thing. The multiplier, now this is the multiplier towards the basic decibel value. If it was 10, 12, 20, whatever, it would be the 1 or the 2 or the 3 in front. Now let's take a look and see. Here we go. Here's what turns out. By the way, you don't need a calculator. You don't need a slide rule. You can take a piece of scratch paper and do this, and this is what I'm going to show you. First of all, any number to the power of 0 is 1. So 10 to the 0 is 1. Here's what's interesting. If you make a chart on a piece of paper, you can do this. You can go from 0 up to 9, even 10 as far as that goes, but I'm going to do it this way. Every 3 dB, this is what's interesting. Every 3 dB, it doubles. So therefore, it goes from 1 to 2 to 4 to 8. Now, if you keep on going, like what is 3 dB more than 9 is going to be 12. Now, I want to point out something. The only difference between 12 and 2, believe it or not, is that leading 1. And lo and behold, 8 doubles to 16. 3 dB more doubles to 32. 3 dB more doubles to 64. Now what happens is these numbers are not dead on. By the way, they're only 98 to 99% accurate. What I'm trying to say is you can scratch this out on a piece of scratch paper and you can be really, really close. If you want closer, go grab a slide rule or a calculator, one or the other. But right now you can interpolate values quite closely. What you do, 64 doubled is 128, but we slide this back, just a little bit of a correction. This is the only time we do it, and it makes it 125, then 250, and then 500. You say, okay, but I don't want to have to do it this way. What I'm going to show you is this 16 can be slid over into this location, but what you do is you make it 1.6. You take this 32 and slide it over into this location, and it's not 32, but rather it's 3.2. The same thing with the 64. You slide it over into this location, it becomes 6.4. You do the same thing up in here with a 125. You can slide it over here, or you can slide it all the way over here, and it becomes 1.25. You can take this 250 and slide it over into here, and it becomes 2.5. You can take the 500 and slide it over into here, and it becomes, guess what? 5. As it turns out, we would then wind up with this chart right in here, and this chart here is at the most, it's only 98% accurate. However, if you want to ignore that little bit of a percentage, almost everything down this list is 99% accurate. Now, this is the basic dB, and I'm going to show you how we use that. But notice again, look what happened. You start off with 1, you double it to what? 3 dB doubles. Another 3 dB doubles. Another 3 dB doubles. So 8 doubles to, guess what? 16. If you went 3 more than 9, that would be 2, or 12, if you want to call it that. And what's really amazing is that this chart is so simple, so easy to make, and it is so accurate. Now, all this gives you is just the basic dBs. That's the number in front of the decimal point. And notice, if you will, though, some of these are 2.5, which includes the number behind the decimal point. Now, somebody says, okay, what good is this? Well, here's what we find. Let's go down here below as an example. Actually, I have one example right here. If you have 3 dB and somebody says, I have an antenna with a 13 dB gain, look what we did. 3 dB, that's this basic dB is the 3. Well, this basic dB is a gain of 2. However, you have a multiplier. That's where the multipliers come in. So you have a multiplier of 10 to the first power, which makes it 10 times as much, or if you will, 13 is going to be gain factor of 2 times 10, which is 20. There you are. That's the gain of your antenna. We're talking about power gains now. We're not talking about voltage or current gain. But in power gain, everything doubles. It's just a really, really simple chart to make. And if you have a slide rule, you can look at this and read it right off the slide rule within just a gnat's eyebrow. It's really close. Now, let's go down here a little bit further. This number here that I did, 13 dB, because this is decibel, decibel meaning factor of 10, what happened is your 13, if you do it on a calculator, here's what you got. See that 1 right there in front of that behind with the power of 10? That is your multiplier. If you were to take 10 to the 0.3, 10 to the 0.3 will give you something very, very close to 2. If you put the multiplier in there, it becomes 1.3, not 13. Up here we write 13 dB, but on the calculator you would put in 1.3. There's a hidden decimal point there. And if you keep in track that that hidden decimal point is there, you'll find it comes out to be very, very close to 20. That's a gain of 20. Let's go down here. Somebody says, I've got an amplifier with a power gain of 38 dB. Well, you look up here in the chart and you find 8 dB. Where is it? Oh, there it is. 8 dB is 6.4. Now, just a second. Sorry about that. I didn't know where the mute key was. Now, 38 dB is 6.4 times 10 to the power of 3, or 6,400. If somebody says, I have an amplifier with a power gain of 27 dB, the 7 dB is right here, a gain of 5, but it's a gain of 5 times 100. And how come I got 100? Because that's 10 to the 2, which is same thing as hundreds. So what you've got? That is therefore a power gain of 500. Where did we get to the 500? Always take your basic dB right here. That's what we call the basic dB. The number in front of that is the multiplier. Just like it was in the color code for resistors, it's a multiplier. It makes it really simple and really good. Now, what about values in between? Well, you can interpolate in between, say, for instance, 6 dBs and 7 dBs. But remember, it's not linear, it is logarithmic. So therefore, halfway between these two in dBs is going to be a little bit more than half in terms of a factual number. So it's going to be somewhere between 3.2 gain and 4 as a gain, basic dBs. But just figure it's going to be in there somewhere, maybe about 3.6, something like that. You'd be surprised how accurate you can get with this little simple paper chart. So what you can do is just take a piece of paper and you can line this out, and it helps you to understand dB so they're not mysterious. At least that's what it was for me. And I'm not a mathematician. I need every little simple thing I can get. But it is 98% at the lowest and 99% for the most part, without interpolations. Interpolations, well, that depends on how good you are at interpolation in logarithmic factors. Questions? Does this make sense? It is so simple. And for somebody that doesn't have access to a calculator, or doesn't know how to use it if you got it, or a slide rule, and this is becoming a lost art. By the way, what is the normal accuracy of a slide rule in the hands of a proficient operator? 0.1% error.
That's crazy.
So don't let somebody tell you slide rules are not accurate. By the way, the SR-71 was made strictly with slide rules. There were no calculators involved.
Wow.
Okay, I'm open to questions. Does this make sense? That's the first thing. I just collapsed these three charts into one, which is right here. This is really how it works. You just go around the circle, constructing this, put it together, and you got something you can use. It's a useful chart. It's
awesome.
I think it's amazing how close you can come with a piece of, let's say, scratch paper.
Well, this does make sense. Take a little getting used to. Dave, I wonder if you can copy and paste that link into a chat window. If that's not asking too much, then I'll open it locally.
By the way, all of this is on my website, and you can download this and print it out. I'm going to show you one more thing. You can do it with a PDF, or you can come over here, and there it is in HTML. So
perfect.
So a chat window, huh?
Well, it would save my way trying to drill through the website to get there. That's all.
Well, I don't know how.
I think I have it open. Hold on a sec.
Don't worry about it.
Anybody else? Now, for me, I like to keep things simple because sometimes you can get really deep really fast. You know, like stick your toe in the water. That's one. Get wet. That's number 2. And number 3, snorkel gear required.
That's a good way to put it. I like the chart. The chart makes sense. I could draw it.
By the way, years ago, in the early days, when calculators were a 4-banger calculator with scientific notation was $150, and a lot of students could not afford to buy one.
Yeah.
We used to teach how they would make this chart so they could take the FCC class for FCC, like second class or first class license. Because in Montana, that's what we had. We had students who were going for their FCC commercial license. You can go into a classroom empty-handed with a scratch paper and where they would not allow you to bring in certain things. This one here, you can make it on site.
Dave, I have a question for you.
Fire away.
Is your factor the same thing as a power ratio?
Actually, the power ratio is the whole thing, not just the whole factor. Yes, the whole factor is the power ratio.
Thank you.
There's in engineering, of course, they have the formula for this. They say, okay, the 10 times the log of the power out over power in, so that's your power factor. Yes.
Okay, very good. Thanks.
There are a lot of people that if you mention logarithms, they get scared. So I like to look at it this way for us simple folk. Any other questions?
Excellent. Where do I get one of those 29 dB amplifier antennas?
Well, that was a series of transistors, of course.
Excellent.
Dave, quick question.
Fire away.
So when you're comparing antennas, this works as well then?
When
In
you're
other
doing
words,
what?
when you're comparing antennas, in other words, they talk about this antenna has like a 3 dB gain
Oh,
over
yes,
another type. Okay.
that is correct. Yes. So in
Good
other words,
stuff.
if I put up a 3-element quad antenna, for instance, and they tell me it has an 18 dB gain, I look down here on my 8 and I say, okay, that's 6.4 times 10, which means it has a gain of 64, a forward gain. Yeah.
Cool. Okay.
Somebody says, I have this antenna I want to sell you that's got a 25 dB gain. I'll say, how do you measure that? Because 25 would be an awfully high number for an antenna like that. 5 dB would be 3.2. In other words, 320 off the front end of that antenna. I think that's ridiculously high.
That was obviously a marketing computation.
Well, what I like about this chart, it is so easy to make and so usable. And besides it, if you have to do it more than once, it kind of grinds it into your mind a little bit better. And I do have here how to use a calculator. What you do is you split the number. Remember to put in that hidden decimal point. Because if you put in 10 to the 13th, you'll get an awfully high number. But if you put in 10 to the 1.3, that hidden decimal point is what brings it to you correctly. And 10 to the X. You put in that number and then you go 10 to the X. During the slide rule days, we always had to do the multiplier separately, because what we did is we took the slide rule to get this basic factor. This is what we did. We got the basic factor with the slide rule, and then we always did the multiplier by just simply a power of 10. All right, if you don't have any other questions, we're all done.